Hi, this is a short introduction to the homework on Module 1. I won't go through all the problems, I'll just go through some of the problems that there may be issues with. So the first problem is just a straightforward calculation of the mass of a room. So what you can recall is that volume is always equal to, in this case, length cubed, because we're assuming that this is a cubic room, length times width times height. Other ways that you can have volume measurements would be, like a cylinder, which would be pi r squared h, or 4/3 pi r cubed, say, for the volume of a sphere. So in this case, you're just doing a straightforward calculation using density is equal to mass over volume. The next problem that I want to point out is 1015. Here you need to be a little bit careful because you're being given mixed units. They're giving you the gauge pressure in kilopascals, and they're giving you the area in centimeters squared, and they want you to determine the mass of the car. So recall that pressure is equal to force per unit area. And recall that force is just a weight, right? And that equals m times g. Just have to be careful here of units because a Pascal is equal to a Newton over a meter squared. And this footprint here is being given in square centimeters, and these units are in kilopascals. So just watch your conversions here. This problem, they're asking you to determine the pressure exerted by one heel on an area 0.45 centimeters squared. Include the appropriate units. In this case, you want your units to be newtons per meter squared. And again, you've just got to be careful about your area here. Next problem is dealing with Archimedes' principle and buoyant force. And you've got a scuba diver displaces a certain volume of water, and we know her total mass, and they want to know the buoyant force. Well, the buoyant force is going to be equal to the mass of water that's displaced times the acceleration due to gravity, because this is just a force. And to determine the mass of water, you're going to need to know, the density of water. I'm just making this a little bit clearer. The density of water you can assume is 1,000 kilograms per cubic meter. And the volume, so you can find the mass of the water that's being displaced. And then it's asking whether the diver will sink or float. So what you want to do is compare the force of the diver, which is really equal to her weight, to the buoyant force. And once you do that, you'll be able to determine whether or not she sinks or floats. All right, the next problem asks you to calculate the true mass of a piece of aluminum. You weigh it in air. When its apparent mass is weighed in air. And they're giving you the density of air, the density of aluminum. So what we know is that the volume of the aluminum is going to displace an equal volume of air. And we also know that the actual mass of the aluminum minus the apparent mass should equal the mass of the air. Using that, and then again, going back to our density equation right here, if you know the density of the air and the mass of the air, then you can calculate the volume of the air. So we now know that the mass of the aluminum minus the apparent mass, is going to equal the density of the air times the mass of the aluminum over the density of the aluminum. So all we're doing here is taking a look and rearranging these equations, and using this, you should be able to calculate out the true mass of the piece of aluminum. 1016, I did one very much like this in the lecture as an example, so you can take a look at that. Problem 1017, you've got a house at the bottom of a hill, and you're wanting to determine the water gauge pressure at the house. So there's a head of water up here, and you're wanting to determine the pressure at the bottom of the house. So the height of the water here is 6 meters, plus you've also got to take into consideration the force of the water in this vertical Y direction to determine the gauge pressure. So the gauge pressure is just going to be the density of the water times G times the height. And using trig, because they're giving you the angle here, you can determine what that height is and add that to the height of 6 meters to find the total gauge pressure being exerted. And then the next question is, how high could the water shoot if it came vertically out of a broken pipe at the front of the house? So here, you just have to think about how high up could the water shoot and think about what it's doing at the top and whether or not it's moving. And you should be able to make a determination on that. So for problem 23, we're looking at trying to determine what fraction of concrete will be submerged when it floats in mercury. So because we're floating, that means that the sum of the forces has to equal 0, which means that the weight of the mercury, which I'm showing right here, has to equal the weight of the concrete, because that buoyant force is equal to the mass of the concrete times the gravitational acceleration, which is the weight of the concrete. So if we take this and rearrange it, then the volume that's submerged over the total volume is just going to be equal to the density of the concrete over the density of the mercury. And you can use this equation in its most general form to solve these problems to make determination on percentages. So when you take those two numbers, you're going to get a ratio, and then you should multiply by 100 to get the percent. All right, the next problem says that you're trying to make a raft out of an empty bottle. What's the minimum number of soda bottles that you're going to need to be able to stay dry on the raft? So basically, again, you want the buoyant force of the raft here to equal the weight of the child. So those two forces are equal. So again, looking at density, gravitational acceleration, and volume, you can find the buoyant force of the raft, which is just mass times G, right? Because this right here, volume times density, is equal to the mass of the water that's being displaced. And then, or that the bottles are displacing. And then you've just got to multiply by n to get the minimum number of bottles, so that you can set this as an equality here. So n is going to be the number of bottles. All right, so the next problem says you've got an athlete on dry land, weighs 78 kilograms. When they're submerged in a swimming pool, hanging from a scale, they've got an apparent weight of 2.7 kilograms. So again, you can figure out the total volume displaced here, recalling that the buoyant force plus the force of the swimmer is equal to their apparent mass times G minus the weight of the swimmer, all has to add up to equal to 0. So basically these two forces, the buoyant force and the apparent force on the swimmer due to his apparent mass times G, has to equal the weight of the swimmer. And so they sum up to 0. The next part of the question just asks you to determine the specific gravity. And here, recall, specific gravity is dimensionless. It's going to be the density of whatever the object is over the density of the water. Problem 1042, you've got an aorta and the blood is passing through the aorta, and they want you to calculate the average speed of the blood flow through an artery that has a total cross-sectional area of 1.8 centimeters squared. So here you're going to use the equation of continuity that says A1V1 equals A2V2 to make that determination on the average speed. Problem 51 is an application of Bernoulli's equation. They want you to estimate the air pressure inside a hurricane when the wind speed is equal to 250 kilometers per hour. You've got to be careful of your units here. So if we look at Bernoulli's equation down here, and remember this is conservation of energy, really basically that the amount of energy in equals the amount of energy out. There are a couple things that we can do to simplify this particular problem. If we assume that the height from the inside to the outside of this is equal the same, then these two values, this potential energy due to the mass, is going to cancel out. And then if we assume that the velocity on the outside edge is equal to 0, this whole term is going to cancel out. And so you can use this to estimate the pressure that's inside that hurricane. You know its initial velocity, and you know the outside pressure, assume that's 1 atmosphere. All right, problem 1054, you're looking for the power needed to drive a fluid through a pipe. Ignoring the viscosity, take Q as the flow rate. Remember, flow rate Q is equal to meters cubed over seconds, and that equals the area times the velocity. And if you take a look at this then, and we use our equation for pressure equals force per unit area, and rearrange it, we know that the net force equals delta P times A. And recall from first semester physics that power is work per unit time, which we can also, because remember work is force times distance, and power is over time, remember d over t is velocity, we can also say that power is equal to force times velocity. So if you look at this equation that says that the power is equal to the net force times the velocity, and Q is equal to A times V, you should be able to come up with an expression to determine the power needed to drive a fluid through that pipe. Problem 1057 I've deleted. It's quite involved, so don't worry about that. Problem 1063 is asking you to determine whether or not flow is turbulent or laminar. Remember, laminar is a smooth flow. Turbulent, obviously, is not smooth. And the Reynolds number, if the number exceeds 2,000, that is considered to be turbulent flow. So this is the equation that you can use to calculate this out. In this case, they're giving you the values that you need, and they're asking you to calculate the Reynolds number. You are probably going to need to look up, yes, the viscosity of blood in order to solve this, and then the rest of the values they're giving you. Be careful, again, it looks like unit-wise, you may have to convert here because you've got to use the correct density for blood, and you've got to use the viscosity, so be careful about your units here. And I think that is it. The rest of these are misconception questions. Feel free to reach out if you have any questions on the homework, and good luck.